Thank you for patience. My presentation is managing the operational reliability of intelligent trucks. Global competition and rapid technological advancement have shortened products development cycles. Manufacturers ensure reliability through a branded service system, crucial for maintaining life cycle responsibility, especially for modern trucks. Modern vehicles demand advanced technical preparation and corporative service network, which manage life cycle accountability and provide comprehensive data on vehicle operation and repairs. Trucks, unlike passenger cars, require dedicated service infrastructure. In the Industry 4.0 era, product customization increases maintenance challenges. Lifecycle management is hindered by varying owner practices, emphasizes the need for enhanced BSS efficiency and adherence to maintenance protocols. Planning includes vehicle type and each costume with maintenance data collected manually or automatically via diagnostics. These processes really rely on legal frameworks for data management and support long-term operational planning in challenging environments. Decision support system integrate data collection, analysis, and user interfaces for strategic management. Simulation models with DSS optimize decision across the service system, ensuring adaptive and efficient responses. Models like statistical data analysis predict failures and monitor service performance. Failure trends enable tailored maintenance strategies using statistical modeling. Example, analyzing truck starter failures reveal improvements over time, supporting reliability enhancement and better operational planning. Time series forecasting anticipates part replacement, incorporating seasonal trends. Predictive accuracy ensures timely interventions and optimize maintenance schedules. Service execution times follow specific probability distribution. These insights improve resource allocation and response planning for service centers. Agent-based and event-driven modeling simulates vehicle operations within service network. Parameters like service times, parts availability, and staffing levels optimize dealer network performance under varying conditions. Statistical validation ensures model reliability. Result confirm alignment between simulation outputs and real-world data, validating the approach for decision-making. Lifecycle-based reliability improvements boost competitiveness and operational efficiency. DSS and simulation models allow adaptive strategies ensuring optimal service system and continuous data updates. Thank you for your attention.